Hello, in this video we study partial fractions. We will learn how to solve integrals of the form integral px over qx, where p and q are polynomials. Okay, actually we already saw some problems like that before, but today we will list most of well-known integrals. The first example, we need to find antiderivative of the function 1 over x squared minus 5x plus 6. So you have x squared minus 5x plus 6, that is quadratic function, right? And in the previous lecture, we studied three forms involving quadratic functions. First one is x squared minus a squared minus x squared, and a squared plus x squared. You might involve, square root, that's fine. But when you see, one of these forms, so you might think about trig substitutions. Is that correct? The first one, you put x equal to a sequence of theta. The second one, you put x equal to a sine of theta. And the last one is x equal to a tangent of theta. Right? And then, we can solve such integrals easily. In this case, yes, so you have x squared minus 5x plus 6. So you might think about, we might rewrite, the function right here as one of these forms. Is that right? One of these forms. But, that is too complicated. Let's do in the following way, because we don't know. We don't know if this polynomial has zeros or not. Is that correct? So we need to consider two cases in here if you see, such polynomial. So the first thing we need to do is to check if the polynomial has zeros or not, right? So for such problem, it's easy. You just check, negative, you check b squared minus 4ac, right? Where b squared is negative 5 squared minus 4ac is 1 times 6, right? So you have 25 minus 24, which is 1, bigger than 0. So when this value is bigger than 0, yes, we have two zeros, right? The polynomial has two zeros. Perfect. In case if your polynomial does not have any zero, means this value is less than 0, right? So that polynomial is always positive or negative. It depends on the sign of x squared in here. But since the sign here is plus, so maybe positive, right? But it says the graph of that parabola does not intersect with the x-axis. In that situation, we will treat differently. But in the case when quadratic polynomial has zeros, so we treat that in a very easy way. Okay, let's do this. So we know has two zeros in here. Perfect. Let's factor that out, right? Let's factor that out. So I write 1 over x squared minus 5x plus 6 equal to, you can find two zeros by quadratic formula. Let's write that formula, right? x12 equal to negative b plus minus square root of b squared minus 4ac over 2a, right? So for this polynomial, you have negative b is 5 plus minus 1. We just calculate, b squared minus 4ac over 2. So you have 3 or 2. That means, polynomial is 1 over x minus 2 times x minus 3. Okay, you see, we have this form. Perfect. Now I can convert, I can break this function into two functions. How? I write, x minus 2 in here. We just rewrite 1 as x minus 2 minus x minus 3 over x minus 2 times x minus 3. And then that is x minus 2 divided by x minus 2, x minus 3 minus x minus 3 over x minus 2 times x minus 3. You see? We just break the function into two functions, right? And then we simplify x minus 2 and then x minus 3 in here. We get 1 over x minus 3 minus 1 over x minus 2. And now we can find antiderivative of each function easily, right? So I have antiderivative of x squared minus 5x plus 6 equal to dx over x minus 3 minus dx over x minus 2. And this is nothing but ln of absolute x minus 3 minus ln of x minus 2 plus constant. Or sometimes they write ln of x minus 3 divided by x minus 2 absolute plus c. Okay, so that's how we can solve certain integrals, right? But in the case, if x squared, if the polynomial right here has 2 zeros, if that has only 1 zero, I mean the double zero, perfect. It is even easier. You see, for example, if you have dx over x squared plus 2x plus 1, right? So you can rewrite that as dx of x plus 1 squared. You see, negative 1 is a 0, right? And the multiplicity of this is 2. So this integral is much easier than previous one. You can use x plus 1 to negative 2 in here dx, and then you use the power rule. You get what you need, right? Or that is negative 1 over x plus 1. Agree? The case when the polynomial right here does not have any zero, so that case would be more complicated. Okay, let's solve one example and we'll see how that works. I need to solve the following integrals. Just modify a little bit. Let's say x squared plus 2x plus 3. Okay, so you calculate b squared minus 4ac, that is 4 minus 4 times 3, which is negative 8 less than 0. So that means x squared plus 2x plus 3 does not have any 0. Alright, in that situation, we need to rewrite this into this polynomial as u squared plus a squared. Okay, as u squared plus a squared. So let me write that x squared plus 2x plus 3 equal to x squared plus 2x plus 1 plus 2. Why we just break 3 into 1 plus 2? Because we want to use the following identity: a squared plus 2ab plus b squared equal to a plus b squared. Or sometimes you might have a squared minus 2ab plus b squared equal to a minus b squared. Right? So in this case, a is x, right? B, you can find b from here, from 2x. So how to find b? You have 2a, which is x, right? So the b should be 1. Is that correct? So that means you need to add b squared, which is 1 squared right here. That's why I break 3 into 1 plus 2. Right? Alright, so according to this, I have x plus 1 squared plus 2. And our integral looks like dx over x plus 1 squared plus 2. You see, what's this? That is du over u squared plus a squared, where a is square root of 2. So you need to use trig substitutions in this situation, right? Okay, let's do that. We need to use trigonometric substitution. All right, in this case, I think we need to put u equal to a tangent of theta, a tangent of theta, and du is a secant square theta d theta, right? And we have u square plus a square is a square tangent square theta plus 1, which is a square secant square theta. Now we can rewrite your integral in terms of theta. When you do this substitution, I didn't mention this, right? But when you put u equal to x plus 1, the x is just du, so we don't change anything, right? In the integral, you see that? But if this part is a little bit different, so sometimes we need to change. Agree? Sometimes we need to change. So my integral is du is what? Is a secant square theta d theta. Oh my goodness, I think we already know this integral, but that's fine. We already know this integral because we solved this several times. Sorry for this. So this is just 1 over a d theta, right? And that is 1 over a theta plus c. And from here we can solve for theta. So that is nothing but 1 over a tangent of u over a plus c. And u is x plus 1. So I have x plus 1 over a is square root of 2, right? So let me write square root of 2 in here, square root of 2, and then plus c. I just forgot about this. We have this integral already. This integral is just 1 over a tangent of u over a plus c. Sorry. We have some integrals involving inverse function before, right? So if you remember that, just copy the formula. But in this case, I just show you, how to work with trig substitutions again, right? You see, actually, these two examples are very typical. I repeat again, right? In the first example, you have x squared minus 5x plus 6. You need to check if this polynomial has zeros or not. If that has 0, 1 or 2, whatever, you may solve this way. If there is 2 zeros, so you break the function into, two functions like this. And then you integrate each of them. Okay? If you have polynomial and that polynomial has a double 0, so you may use the power rule. And in case if that polynomial does not have any 0, so you might rewrite that as u squared plus a squared. And then you use trig substitutions. Again, if you remember this formula, so you are good to go. Okay, so this is very typical one. Okay, let's move to another examples, of partial fractions. Now let's consider another very typical integral involving fraction. You have integral of 5x squared plus 50x plus 6 over x cubed plus 2x squared plus x. Again, we need to work with the denominator, right? Like previous example, we need to find if the denominator has zeros or not. So if you consider x cubed plus 2x squared plus x, and you put that equal to 0, right? And you solve for the x just to find how many zeros it has, okay? Just 5 zeros, okay? So, x is common. You can factor that out. You have x squared plus 2x plus 1 equal to 0. And here you have x. We have seen, x squared plus 2x plus 1 is x plus 1 squared equal to 0. So the polynomial has 2 zeros, 1 is double, or multiplicity of that 0 is 2. So x equal to 0 or x equal to -1. All right, in this situation, how can we do? So I will write the following one: 5x squared plus 20x plus 6 over x plus 1 squared. So, in the denominator you have x, right? X plus 1 and one more x plus 1. Then I can rewrite this function as the following: a over x, the first factor, plus b over x plus 1, the second factor, and another one is square, right? Plus c over x plus 1 square, where a, b, c are numbers. Are scalars. So if you can find a, b, and c, so you already break the function into 3 functions, and you can see that we can integrate each function right here easily. Is that right? So this is ln of x, this is ln of x plus 1 absolute, and here we use the power rule, right? All coefficients a, b, c can be brought out of the integral easily. So our job is to find ABC. Okay? So how to find ABC? Again, you do very elementary operation. You just, make a common denominator. Make a common denominator on the right hand side part. And then you write that in the form of polynomial on the top, right? And then you compare with this polynomial. Okay, let me show you how to do that. So I will have common denominator, which is x plus 1 square. That should be the same right here. Is that correct? And in a, I need to multiply a with the x plus 1 square. Is that correct? I need to multiply b with what? With the x and x plus 1. And the c with x. Is it? Right? So now I will open all parentheses on the top. I have a x squared plus 2x plus 1 plus b x squared plus x plus cx over x plus 1 square. Then I will group all terms with x squared together. I have a plus b x squared. How about x? For the x I have 2ax, bx, and then cx. So I have 2a plus b plus cx, and the free coefficient is a and 1 only. So I have a divided by x plus 1 square. You see, this function is equal to this one. They are the same, right? That's why you have 5x squared plus 20x plus 6 equal to a plus b x squared plus 2a plus b plus cx and plus a. So you have two polynomials, two quadratic polynomials equal, right? So you just compare the coefficients because they are equal for any x, right? So that means their coefficient, their corresponding coefficients should be equal. 5 equal to a plus b, 20 equal to 2a plus b plus c, and 6 equal to 2a. I have the following system: a plus b equal to 5, 2a plus b plus c equal to 20, and a equal to 6. It is very easy system. So you plug 6 into the first equation, you get b equal to 5 minus a, which is 5 minus 6 is -1. And from the second equation, you get c equal to 20 minus 2a minus b. And that is 20 minus 2 times 6 minus negative 1, right? And that is 20 minus 12 plus 1, and that is 9. So I already have a, b, and c. Then I'll just plug a and b and c into this formula. So I write this is equal to, what is a? A is 6, right? So I have 6 over x plus b, I think b is negative 1. So I write minus 1 over x plus 1. And c is 9 plus 9 over x plus 1 square. And then you integrate each function in here. That's it. Then your integral, I write here, the integral is equal to dx over x, 6 in here, minus dx over x plus 1 plus 9 dx over x plus 1 square. This is 6 ln absolute of x minus ln of x plus 1 plus 9. So here I think we solved that in the previous example. We use the power rule, right? We convert like x plus 1 to negative 2 dx. And this is, minus x plus 1 to negative 1. Or we can write the general solution is ln x minus ln of x plus 1 and minus 9 over x plus 1 plus constant. You see, that's how we can solve such integral. Again, right, we need to handle the denominator. We need to handle the denominator. We need to see how many zeros it has. Okay? That is general idea, because you can solve the very first example like this. Let me show you this, right? The very first example, this one right here. Actually, in this step, if we follow the idea we just show you, right, I can write 1 over x squared minus 5x plus 6 equal to a over x minus 2 plus b over x minus 3. Because we already found that, this polynomial has 2 zeros. You see that? 2 and 3. So, we need to factor this, right? And then once we factor that, we can rewrite as this form. And then, again, I need to write, a x minus 3 plus b x minus 2, right? Divide by x minus 2 times x minus 3. And then we compare this part with the 1. We compare this one because we have 1 right here, you see? So if you solve that, you have, a plus bx, because in this you have ax and bx, right? A plus bx minus 3a minus 2b equal to 1. Here we don't have any x, that means, a plus b is equal to 0. And we have negative 3a minus 2b equal to 1. You see, from the first equation, I have a equal to negative b, and I plug this into the second one, I get negative 3 negative b minus 2b is 1, or b is equal to 1. From here, I get a also equal to negative 1. Done. That's what we got in here. A equal to negative 1. You see, this is a, and this is your b. Does that make sense? So, this is very general method, okay? If you want to break your functions into different functions in here. Of course, simpler functions that you can integrate easily. So, it turns out that solving such integrals is to factor or break the function into simpler functions, right? So let me show you a couple of problems before we finish this video, right? And then I think that we don't need to solve integrals in this situation. But let's talk about this integral. 2x cubed minus 4x minus 8 over x squared minus x times x squared plus 4 dx. Again, we need to work with the denominator first. I have x squared minus x squared plus 4 equal to 0. So, this is not 0, so we don't need to care about it, right? I just care about this. So I have x and then x minus 1, and then x squared plus 4 equal to 0. So your denominator can be factored like this. Okay. Now I can rewrite, using the same idea we just used. I can rewrite this as the following one: 8 over x minus 1, x squared plus 4 in here. I can write it is a over x plus b over x minus 1 plus cx plus d over x squared plus 4. Okay, why we have cx plus d in here, right? In the previous example, we don't have cx plus d. We have this because, x squared plus 4 is already prime. You cannot factor that out. Does that make sense? If you compare with the previous one, let me rewrite that in here, right? I think it was 5x squared plus 20x plus 6 over x and x plus 1 square. So, when you have this, right, you write a over x plus b over x plus 1 plus c over x plus 1 square. This part is not prime. I mean, this part, in the sense that, x plus 1 square has a 0. So that's why you don't need, cx plus d in here. Does that make sense? You don't need that. Because if you have cx plus d, so basically you can simplify. Does that make sense? If you have cx plus d over x plus 1 square, so you might convert this into, just some number m over x plus 1 square and then plus n over x plus 1. Does that make sense? Because, you might write cx plus d equal to cx plus c plus d minus c. And then, you copy this cx plus c. You divide by x plus 1 square and you get, this form. So that's why in this case, you don't have, cx plus d. You don't have in here. You just have c. Does that make sense? But in this case, there's no way to simplify that because x squared plus 4 does not have any 0. So when you write in this form, you need to have cx plus d in here. And the polynomial in here should be, has degree less than 1 if you compare with this. Agree? And now you do almost the same thing. Just multiply them all together, get a common denominator. And then you compare what on the top with 2x cubed minus 4x minus 8. Does that make sense? Okay, let's do this, right? I have, since here we have x, I need x minus 1 times x squared plus 4. So I have a x minus 1 times x squared plus 4. For the b, I need to multiply with the x and x squared plus 4. And for the next one should be cx plus d times x and x minus 1. Everything divided by x minus 1 and x squared plus 4. And now you just need to compare these two guys. So, just careful in computation, right? Okay, let's do that. Okay, given that this is pretty long, but that's fine. We need to solve that to the end. Okay, so I have to, for this out, I have x cubed plus 4x minus x squared minus 4. That is for the A. For the B, I have b x cubed plus 4x. And here I can write here cx plus d and then x squared minus x. So I have cx squared, cx cubed, sorry, minus cx squared plus dx squared and then minus dx. Everything divided by x. X minus 1 and x squared plus 4. And now I need to group, right, all terms with x squared, x cubed, x and free coefficient and compare with 3 with 2x cubed minus 4x minus a. Okay, let's see where we can see x cubed. We have x cubed in here, x cubed in here, and x cubed in here. So that means we have a plus b plus c x cubed. Now x squared in here, x squared in here. So I have plus minus a minus c plus d x squared. You see? And then for the x, I have 4x in here, 4x in here, dx in here. So basically, that is minus 4a. I can write, okay, plus negative 4a, okay? And then plus 4b, and then minus d. And the free coefficient is just, right here, minus 4a. Now let's compare two polynomials. Let's start from the free coefficient negative 8 with negative 4a, right? So I have negative 8 equal to negative 4a. That is the first one, and you can see right here a equal to 2. And then move to the x, right? You have negative 4 on the left hand side. On the right hand side, you have negative 4a. Let's see, we have correct or not. I think we have just plus 4a in here because, a with the 4x in here, so we have 4a. Sorry for this. So you have plus, okay? That means you have 4a. Okay, let's check again. And then the b in here is plus 4b. And then the x in here, you have minus d equal to negative 4. Okay, and then we move to the x squared. We don't have, we have negative a in here, minus c plus d. So I have negative a minus c plus d equal to 0. And you have a plus b plus c equal to 2. I plug a equal to 2 into, the last three equations. I have 8 plus 4b minus d equal to negative 4, negative 2 plus minus c plus d equal to 0, and then 2 plus b plus c equal to 2. So I have 4b minus d equal to negative 12. Negative c plus d equal to, is it correct? Negative a minus c. Okay, that is 2, and then b plus c equal to 0. Now I add two equations here because I have negative d and d right here, right? So d will be cancelled out. I have 4b minus c equal to negative 10. And then b plus c equal to 0. If I add two of them together, I have 5b equal to negative 10. And then I have b equal to negative 2. Oh my goodness. So I have b equal to negative 2. I plug this back here. I get c equal to negative b, which is 2. Right? B and c. Now I can, plug, b into this equation to find d. From here, I can find d is equal to 4b plus 12. So 4b is negative 8 plus 12 is 4. You see, it is long way. Anyway, we solve this. Perfect. Then I can plug A, B, and C and D into the formula right here, into this formula. We have that. Okay, let me copy in here, right? So what is A? A is 2, so I have 2 over x. B is what? B is negative 2, so I have minus 2 over x minus 1. And C is 2x, right? D is 4 divided by x squared plus 4. You see, that is our function. So you have this function, perfect, but you still need to integrate, right? This function is okay, it's easy. This is also easy, so we need to care about this guy. Let me write here. From here I get, if I take antiderivative, so I can write 2 ln of absolute of x. This guy is minus 2 ln of x minus 1. Okay, so we need to find antiderivative of this function. That means 2x plus 4 divided by x squared plus 4 dx. And we have seen this, right, in when we study trig substitutions. So if I differentiate, x squared plus 4, I will get 2x dx. You see, x dx, on the top you have 2x and then dx. So here you still have free coefficient. That means you need to break this into two functions, right? Again, you have 2x dx divided by x squared plus 4, and then plus 4 times in here dx over x squared plus 4. Perfect. This is already done, because you can put u equal to x squared plus 4, and you get du is 2x dx, and your integral is nothing but du over u, which is ln of absolute of u plus c, or ln of absolute of x squared plus 4 plus c. For this one, we know that is 4 times 1 over a, right? We use arctangent. 1 over a is 1 over 2. Arctangent of x over 2 plus c. So that is 2 arctangent of x over 2 plus c. Now we need to put all together. This one with all this. So you have the answer is this guy plus, I write plus in here, ln of absolute of x squared plus 4, and then plus 2 arctangent of x over 2 plus constant. You see, this is pretty long, but that's how we can solve such a problem. There's no other ways, So look at this one more time. You have a tiny integral in here. You analyze the denominator. You see, the denominator can be factored as product of x times x minus 1 times x squared plus 4. We rewrite that, in this form, right? And then you have to work with the right hand side part, right? You need to make common denominator and everything, and then you group all terms of x, x squared, x cubed, and free coefficient. You make these polynomials, right? And then you compare this polynomial with the one from the original integral, from the original function. You get a system of linear equation. You solve this system of linear equation to find a and b and c, and finally you got this. So you already broke your integral, your function, into similar functions, and then you integrate each of them. Okay, and from here, that is not the simplest one, so you need to use this. You need to break your function into two functions. In one integral you use substitution, in another one you use substitution, and you get an inverse. You see, it is very long, but I think the way, the idea is clear enough, right? So you need to factor your denominator, and then write this form, and just follow step by step. You can solve such integrals easily. All right, so I think I finished my video in here, and again, right, this is not an easy topic, so well, I very encourage you to do homework. Okay, and if you have any questions, please feel free to let me know. Bye.